All right, these are the video notes for 1.5, day 2. So we're going to hit the rest of the solving equations of different types. You've got several methods we'll hit and types of problems today, and I'll just tell you guys right up front, some of this is going to be review. There'll be methods and things that you should definitely recognize. Some of the problems will not be new, and that's okay. Like I said, even though we call it the review chapter, we like to throw some pre-calc level of thinking at you right away in chapter 1, take it up a few notches and get you thinking about how you'd take the more difficult problem, and even though it's based in Algebra 2, and deal with whatever those twists and turns are. So we're just going to get going on the examples. As we get to one example to the next, I'll just kind of comment for you guys, yes, Algebra 2, no, maybe not, and just see what you guys remember. Okay, let's get started with some examples. So to kick off the first one, we would definitely go yes on the I saw this in Algebra 2 question, because we definitely do complete the square, and you do it quite a bit in Algebra 2. There's two reasons to do it. One is to rewrite an equation from its standard or general form for the purpose of graphing. And the other one is solving. Of course, we're sticking with solving here. The other reason that I would just do completing the square at all is because the original function that I'm looking at is not, there's a blank for that, factorable. Factoring is always our first choice. When we look at a quadratic, number one, let's try to factor because that'd be easiest, quickest, but if it's not, then you got other methods, and complete the square is one of them. The other one, which we'll hit today too, is the quadratic formula. Those are kind of just your own personal preference. There are some reasons why you pick one over the other, which I'll explain as we go through. But anyway, for starters, complete the square. So when we're solving and doing complete the square, we want to take our number term, our constant term, and move it over to the other side of the equation just right away. Now, depending on your Algebra 2 teacher, they may have had you work with the 3 on the same side. And you can do it that way, but ultimately you're going to move it to their side anyway. So my feeling is, why not just move it right away? And now as you go through the process, think about your Algebra 1 kind of way of working through the problem. What you do to one side of the equation, you do to the other. So the other thing is, let's remember the process, completing the square. What are you trying to accomplish? Right? You're trying to take a 2-term now expression and create a 3-term expression that has 2 identical factors. And the way you do that is we go half the middle term and square it. So half our middle term, 4, squared is 16. And then we do what's called a counterbalance. So again, think of it as an Algebra 1 step. When I did to one side of the equation, I got to do the other. So if I add 16 on the one side, I got to add 16 on the other side. The counterbalance idea is an offset of 0. So let's say you subtracted 16 to both sides, it would be gone. So it's a 0 effect. We're changing the way the function looks, but we're not changing its characteristics. Its graph, the vertex would be, pattern of change, those kind of things. And also solutions. So now what I do is I take my 3 terms, and I write them as a single factor square. Now, if you think about it for a second, we were doing it as a factoring problem. Yes, those would be the 2 factors, but for the purpose of what we're doing, we're not going to write it as the same factor twice. We're going to write it as a single factor square. And then 19. Now, this part of the problem is complete the square. We haven't done the solving yet. This is getting us in a spot where we can do the solving. And now the rest of the problem is the actual solving part of it. The solving aspect of this is how do I eliminate the squared? And the way you get rid of a squared is an opposite operation idea, so we're going to square root both sides. One thing we need to remember, which is a kind of a simple mistake if you're a little bit rusty, is that in the process of solving an equation, when you take the square root on both sides, it creates a plus or minus. So we want to remember that. And then the last little bit of this would just be solving for x. Typically, we'll write our root second. That's kind of a standard way of writing your answer. So -4 plus or minus the square root of 19. The idea with the plus and minus being that because it's squared, if you plug it back in and you square the positive or you square the negative, you get the same result. So square root both sides, just remember your plus and minus. So complete the square is about half the work, solving is the other half. Okay, let's do a little bit more with complete the square, and then we'll switch into some of the other methods here. Now, what you guys didn't do nearly as much in Algebra 2 probably is with the lead coefficient's not a 1. You might have done a little bit of it, but when it's not a 1, it shouldn't make it much more difficult. It just has like a little extra step to it, and you got to be clear on your counterbalance. What I'm going to do for starters is the same thing I did in the last one. I'm going to get the number term, move over to the other side. Now, there's a question I often ask my students at this point is the 2. And if we're going to deal with that correctly for complete the square, it needs to be factored out. And usually I'll present sort of 2 ideas. Will I factor it out, like pull it out front, or will I divide it throughout the entire equation? And again, depending on your Algebra 2 teacher, they might have talked about this in they might have had you do it one way or the other. My personal preference is that the things that I will have to do eventually, I might as well just do right away. So if you take the 2 and factor it out and keep it with you on the way in your work, that's fine. But at the very end, when you start, or not the very end, but when you get into the solving part of the problem, you're going to divide by 2 anyway. So why not just divide by 2 right away? To me, it makes more sense. Get that out of the way right off the bat. So I'm going to divide through by 2. Now, when I divide through by 2, that's everything. And yes, over here I have -3/2, and that's fine. We'll just deal with that. So now half the middle term squared, counterbalance, go through those steps. Half the middle term squared, counterbalance. And when you go do that, you don't have to write this, but you may want to think about it as, since you got a fraction over here. It may not hurt just to do that anyway, because we're going to leave it as a fraction. We're not going to do a decimal as part of the answer. So why not just write that as you go? Now I've got my 3 terms that have 2 identical factors. X plus 2 squared, this is 5/2. Complete the square is now done. Switch over to solving, which is by taking the square root. Other things I'd like you guys to start doing right away, if you haven't thought about it already, is when you are taking the square root of 5/2, for example, and when you watch what I just did and I didn't actually do any kind of work, I just did that in my head in like a couple of seconds, is rationalize the denominator. Now I'll show you the work for a second off to the side, but these are the little sort of baby steps that I want you guys to start cutting out of your work and just going, hey, we're honors pre-calc students, I don't need to do that extra work on paper. And it's clear that if you go from the square root of 5/2 to square root of 10/2, that you know what you're doing. Now, what did I do? I applied basically a rule of roots, which is I can split that root top and bottom. And then from yesterday, and it's a pretty basic level of it, rationalize the denominator. As a little bit of a, hey, this is a no-no, this absolutely does not equal the square root of 5. So square root of 10 divided by 2 is not the same, and it's just not a legitimate thing to do. You can't divide the whole number into the root. Because the square root of 10 is not 10. Simple enough, so you're not going to get the 5 out of that. Okay, and then the last little bit of this, again, this work I would just not even have. That'd be in my head work, is get your x by itself, solve for x. So we've got -2 plus and minus square root of 10/2. Again, it's kind of typically a standard way to write it with our root second. Okay, well there's 2 completing the square, and hopefully that gets you guys back into the groove on that. So like I said, about half the work's completing the square, the other half of it is the actual solving. Now, finding all real solutions. So, this is another quadratic. And so I always start by, is it factorable? That's the first question. And clearly no. There's no factors of 1 that can produce a 6 middle term. So that's out. And then if it's not, what are my choices? One of them is definitely complete the square, but as you guys would remember from Algebra 2, the other one is the quadratic formula. Now I'm going to do this problem with the quadratic formula just so we have a comparison, since we already did 2 completing the square. We don't need to really do a third. But let's talk about for a second before I start why you might choose complete the square over quadratic formula, or maybe you feel like, it's just kind of personal preference. They both will work all the time. So things that don't factor, quadratics that don't factor, can universally be solved by complete the square or quadratic formula. But there's a reason why I pick complete the square over quadratic formula, or maybe why I just won't do complete the square is probably a better way to talk about it. If my middle term is even, I like complete the square. If my middle term is odd, for example, let's say this was like a 5 in here. Then I'm not going to go complete the square, because think about what that would require. You'd have to go half of 5/2, square it, 25/4, counterbalance it, and now you're working through the problem in fractions, which, could be done, but again, if I can avoid that, I probably would. So if this is the kind of problem I had, I would just go right to quadratic formula. Complete the square is an algebra process. Quadratic formula is it's basically a calculation, right? It's a formula. So again, sometimes just maybe I like one over the other. Let's go through and look at quadratic formula just so we can see it again. A little quick review for you guys. So remember, in terms wise, it goes alphabetical left to right. So, fill in the formula, right? So b, negative b, that is b squared minus 4ac all over 2a. Then I go ahead and look at what I'm going to simplify, what there is left to simplify out in the root. I've got 36 minus 4. So that's 32. And then I would want to do this as a simplified root. Now again, this is a step that I would think I would just go ahead and do in my head. So that's going to be 2 root 2. What did I do? Like in a matter of seconds, as I see 32 as the square root of 16 times the square root of 2. 16 is 4. Oops, sorry. Let's try it again. 4 root 2. Anyway, 16 and 2, so 4 root 2. And then the last little bit of this is that these things can be all divided by 2, so I'd want to do that. So 3, make that a little bit nicer. Plus and minus. Struggling. Hang on. Okay. So a quadratic formula is a formula in a simplifying process as opposed to complete the square, which is an algebra process, and they both work just fine. And I could have completed the square on this one and got exactly the same answer. Okay, let's get out of quadratic, complete the square, and talk about some other things. So related to the quadratic, and this is a little bit of a sidestep, is the idea of the discriminant. The discriminant, if you guys remember, is just the part of the quadratic formula that sits under the root. It's not a solving process. What it is a way of determining the type of solutions I'm going to get. And so if you're asked to find real solutions and it's quadratic and it doesn't factor, you might just decide to do the discriminant quick as a little side calculation in your head and just kind of see, am I going to get a real solution or not? Now, as far as the rules go, pretty simple ways of thinking about this. Why is it that when it's positive you get 2 real, when it's 0 you get 1, and when it's negative you get 2 imaginary or complex? Is because think about what's going on under the root. If it was positive, you'd have number plus and minus number divided by number. Okay, so the plus and minus is going to create 2 solutions. When it's 0, in the quadratic formula, that part of the problem would actually not be there. So you just have basically your negative b out front over your 2a. Everything after that, gone. So you're really just getting 1 real solution. And then, the reason it's imaginary is because you're taking the square root of a negative, and we should know that when we do the square root of a negative, you produce I. So as the problem goes, discriminant, again, is fairly simple. Just go ahead and plug in your numbers. So we got b squared minus 4ac. That's negative 11, which means because it's negative, you've got 2 imaginary. So again, all the discriminant does for us is determines the type, the number of solutions we're going to have, and what type they are, real or not. Again, pretty easy thing to do. And you may find yourself sometimes, and this will probably pop up other chapters down the road, where you might just go, hey, check the discriminant quick. Would we need to go on with this or not? All right, let's transition to roots for a little bit. So when you're in this, you guys have definitely done problems that are, I'd say, close to this. This might be a shade harder, but not too much. When you're trying to solve, when you got a root, you need to get the root by itself. So usually we'd say isolate the root. Isolate the root is pretty simple. We're talking about some basic algebra 1 kind of stuff here. Check 1 to the other side, and then if you think about solving by taking the square root, this is the opposite of that. So if we want to get rid of a root, we would square both sides. And then I hope that everybody realizes that when you have 2-term parentheses squared, your brain should kick into, that's a FOIL problem, right? Multiply it by itself. And then also, like I mentioned to you guys in the other video, when I see x squared x in number, and then something on the other side, my brain should kick into, get it all on one side. Probably I'm going to be able to factor, or if not, I've got other ways to go. But at least get it all on one side. So if I subtract 5 and add 1x, there we go. Now, you notice it did factor, and I know you see off to the side, there's what it says check, right? And the reason we have to check is that it's definitely possible in the process of doing this work, because you're squaring the 2-term on the other side and you're creating more terms, that you create a solution that doesn't really work. And so root equations have to be checked. And that check takes literally about 2 seconds, and you can just do this in your head. So let's say I put in 4. 5 minus 4 is 1. Square root of 1 is 1. 1 plus 1 is 2. 4 minus 2 is 2. 2 equals 2. There's my check. Put in a 1. 5 minus 1 is 4. Square root of 4 is 2. 2 plus 1 is 3. On the other side, it'd be 1 minus 2, negative 1. 3 does not equal negative 1. That one's out. That's got a name. We call that an extraneous or an extra solution. So you just got to check, because potentially this will happen. And not always, but sometimes you get solutions that just produce negative under the root. Sorry, don't produce negative under the root, but produce a false statement. And then it's just not going to be a legitimate solution. Now, other things that are going to, here's where we get into the territory where you might start to go,